the product rule. It says rule number 5. That's if we're following the textbook. We're not following the textbook. It's just some product rule. Oh, you don't like this? So notice I have u times v. They usually call the u the first, like my first function, and the v the second function. And it says first times derivative of the second plus second times derivative of the first. I'm going to say it again. First times derivative of the second plus second times derivative of the first. And if you go to delta, they actually reverse the order because it doesn't matter because there's a plus symbol. There's a reason why they reverse the order because it makes the quotient rule easier. I've never been a fan. This is how I learned it. This is how I keep old habits die hard. I'll keep my old habits. So I just go by this rule, which is the one that I got from the textbook. Cool or not cool? Cool. So here it is. So before I take this derivative, it says find f prime, which means find the derivative, right? So before I find the derivative, I have this function, and I don't know, the first thing I'm going to do is I'm just going to FOIL it. I'm just going to distribute it. And once I get a polynomial, I'm going to take the derivative. Because I want to see if this product rule is going to work. I am going to try it, just not at this moment. Cool? All right, so here we go. All I'm doing, I'm not taking the derivative, guys. I'm just distributing. X squared times x to the third. X to the fifth. X squared times 3. Perfect. 1 times x cubed. And then 1 times 3. And if you want to put it in order, usually you put it in order with the highest degree. X to the fifth plus x cubed plus 3x squared plus 3. Are we okay? All right. Now, a lot of you, when you guys were doing your delta, you guys were having bad habits of not labeling f and f prime. Try and get in good habits to label what is what. This is my f. And here we go. F prime. Now I'm taking the derivative. What is the derivative of this polynomial? 5x to the fourth plus 3x squared plus, and then that's it, right? Okay. Would we ever use the power rule for something like this? Well, I guess. But I think it's simple enough that I would probably do it this way anyways. But let's go ahead and see if we can get that same thing using that rule, what it says up there. So I'm going to write, let me do it in blue. Using product rule. I said power when I meant to say product. Using product rule, which is up here, guys. It is a product rule. So my product rule says first, it says u. What is u? This is my u right here. This is u, and this one is v. So it says first, x squared plus 1 times derivative of the second. That's what dv dx is. What's the derivative of x cubed plus 3? Perfect. Close it. There's a plus symbol in the middle. And then it says plus second. So I write x cubed plus 3 times derivative of the first. What's the derivative of x squared plus 1? 2x. All I'm doing is following the rule. First times derivative of the second plus second times derivative of the first. The x squared plus 1 is u. The x cubed plus 3 is v. U, derivative of the second, dv dx, plus second, derivative, I guess I'll write it right here. U, dv dx, plus v, du dx. First times derivative of the second, plus second times derivative of the first. Is that the same as what I have in red? What's that? The derivative of x squared plus 1, du dx. What is u? X squared plus 1. So du dx is 2x. Okay, here we go. Is that in blue the same as what I have in red? I don't know. Let's find out. Let's distribute. 3x squared times x squared. 3x to the fourth. 3x squared times 1. 3x squared plus, let's distribute that 2x there. 2x times x cubed. 2x to the fourth. 2x times 3. Combine like terms, if there are any. 3x to the fourth plus 2x to the fourth. 5x to the fourth. And then plus 3x squared plus 6x. Did we get the same thing? Yes. Product rule works. Yes, miss. The power rule? Yeah, I wouldn't use product rule on this one. I probably would have distributed and then taken a derivative. But it's in there. It's a rule.
Oh, so what are instances where like you just absolutely have to use product? Like,
If I have something like 3x times sine x,
oh, yeah.
there's a reason why we're doing, like, we're not just doing it like, oh, let's just do it. Like, we're doing it because there are going to be locations where we must use it. What's up? All du dx means is u prime, and dv over dx means is v prime. That just means derivative. I took the derivative of v with respect to x.
Wait, how did you get, I'm sorry, how did you get, so x squared plus 1, that's u, right?
Yeah.
And how did you get the derivative of that?
The derivative of x squared plus 1 is just 2x, because the derivative of x squared is 2x.
Yeah.
So I went u, which is x squared plus 1, and then this one, the 3x squared, it says here, dv dx, which is, maybe you guys like it like this. So let me write it like this. If I, d dx of uv is equal to the first derivative of the second, so maybe you like that better, plus the second derivative of the first.
No, yeah, that makes sense. I'm sorry, I just didn't know how to get from x squared plus 1 to
Oh, so if I were to tell you y equals, and that's a good question, let's ask always. If I were to tell you x squared plus 1 is y, can you tell me y prime? 2x. Because the derivative of x squared is 2x, right? You brought the 2 to the front, subtract the 1 from the power. And the derivative of 1 is a constant, so it goes away.
Oh, yes.
You know what I'm talking about?
Yes, sorry.
For sure.
Yes, I got you.
Okay. How do we feel? Okay, so here we go. So maybe you guys like this better. So write this again. d dx of uv equals uv prime plus v u prime. First times derivative of the second plus second times derivative of the first. So maybe you guys like that better than the dv dx and du dx. We okay so far? All right. All we're doing is following the rule. Nothing else. Let's see what it says. Let y equals uv be the product of the functions u and v. Find y prime of 2 if u of 2 equals 3, u prime. Okay, so they're telling us all these values. All right, here we go. Y equals u times v. So y prime equals first times derivative of the second plus second times derivative of the first. I haven't done anything. I've just reiterated the rule again. I've written the rule now 3 times in a row. Are we okay? All right, here we go. Y prime at what value? At 2. So hopefully no one gets confused. That's not y prime times 2. It means y prime evaluated at 2. Y prime evaluated at 2 is equal to u at 2. So what's u at 2? 3 times v prime at 2. What is v prime at 2? 2 plus v at 2. What's v at 2? 1 times u prime at 2. What's u prime at 2? There it is. That's all you're doing. So what is that? Let's see. 6 minus 4. So 2. So y prime of 2 is equal to 2. So here's the big deal. Just to make sure. Remember when we did the derivative in red? You guys are 100% sure that's the correct derivative, right? All right. Did we or did we not get the same answer when we did the product rule? Yes. Now there's a proof, that because I know some of you are like, I'm not satisfied with just doing that. I want to see the proof. There's a proof. If you want to see it, swing by either in the morning or after school. It's going to take 10 or 15, or depending. If you are really solid, 10 to 15. If we're iffy, it might be like 20, 25. Are we okay so far? What's up?
We would be tested on both, right?
They're not, the AP exam is not a proof exam. It's not going to be like, prove the product rule. No, this is just application. Cool or not cool? Okay, here we go. There's another rule called, what do you think this one's called? Quotient, and it's for when you're dividing. Yeah, you don't need to take the calculators. All right, here we go, guys. Let's get back at it. Sorry, I had to catch my breath there. This one is called the quotient rule. So what is the quotient rule? Bottom times derivative of the top minus top times derivative of the bottom over bottom squared. There's a song. You want to hear the song?
Yes.
It goes, wait, low D high minus high D low over low low. I don't even know if it's a song. Low D high minus high D low over low low. Low, bottom, D high, the D stands for derivative of the top, low D high, minus high top, D low, D stands for derivative of the bottom, over low low. Low low means squared. Low D high minus high D low over low low. All right. Now, some of you don't like this description. This is just a rule. So let me write it for you the way you like it. D dx, u's in the top, v's in the bottom. That's a v. Let me write it better. Equals, according to the rule, v u prime, low d high, minus high d low, u v prime, over low low, v squared. Do you guys like that notation better? Okay. This one does matter, the order. While the product rule doesn't matter which one you do first, as long as you do one or the other. This one does matter. The order does matter. Cool or not cool? Okay. So, let's see how we... Is there a way I can prove it? Yeah. So look at this one. So go to this one first. Example 10. Because I want to do the same thing that I did a little while ago. So it says, find the equation of the line tangent to the curve, blah, blah, blah. Okay, whatever. So first I just want to find derivative. Are you guys all focused? So... do you guys agree that I can rewrite this expression? Notice I wrote y. I can rewrite this as x squared over 2x plus 3 over 2x. Do you guys agree that I can do that? Okay. And can I cancel one of these x's for the x squared over 2x? So I can rewrite this as x over 2 plus, and then I'm going to bring that x up. 3 over 2 x to the negative 1. Can I do that? I just brought the x up. We just finished doing laws of exponents, right? I just brought the x up, guys. Please, don't scare me. Okay, real quick, I can say this is the same thing as 1/2 x plus 3 over 2 x to the negative 1. Maybe that one you like better. Okay. I'm going to take the derivative of that. Y prime equals, what's the derivative of half x? 1/2. And then what's the derivative of this? Minus 3 over 2 x to the negative 2. So this is going to be rewriting it 1/2 minus 3 over 2x squared. Right? Okay. Oh, they're doing BC over there. Okay, here we go, guys. I'm going to do the same thing, but I'm doing quotient rule, and we're going to see if we get the same answer. Y prime equals, it says low D high, so bottom times derivative of the top. What's the derivative of x squared plus 3? Yeah. Y equals x squared plus 3 over 2x. U is equal to x squared plus 3. V is equal to 2x. The top one is the U, the bottom one is the V. So low D high, so 2x, the bottom, times derivative of the top. What's the derivative of x squared plus 3? 2x. Minus high D low. So I write x squared plus 3 times the derivative of the bottom. What's the derivative of 2x? 2 all over what? Low squared. 2x squared. Chavez, are you sure that's going to be the same derivative? Well, I hope it should be, because it's supposed to be the same. Y prime equals, let's see, 4x minus 4x squared, yeah. Or else I would have gotten it wrong. Minus 2x squared minus 6. Does everyone know where I got the minus 6? Okay. All over 4x squared. Let's combine like terms on the top. 4x squared minus 2x squared, that is 2x squared minus 6 over 4x squared. Are we still okay? Okay, I'm going to separate it into two terms. 2x squared over 4x squared minus 6 over 4x squared. Am I still okay?
Yeah.
Okay. I'll slow down. Yeah, I haven't done anything other than algebra since the only calculus was here in the beginning. After that, I've just combined like terms and just moved stuff.
So y prime is that first one, and then
Bottom, so 2x times root of the top.
I'm talking about the actual part of the bottom. Yes.
Oh.
Yes, all that. How'd you go from there to the next one?
Oh, 4x squared minus 2x squared is 2x squared.
Oh, yes. Sorry.
No, you're good.
Minus 6 over 4x squared, and then for that one.
Yeah, I just, since I have one product in the bottom, I can do that and I can do that. So 2x squared over 4 squared, 6 over 4 squared. Okay. Okay, so here we go. The x squares cancel out, and 2 over 4 is the same thing as half. And then 6 and 4 reduce to 3 over 2, and I still have the x squared. It's in the bottom. Make sure you keep it. And OMG, we should not be shocked. Is it the same as the blue one? Yes. So hopefully that's enough to satisfy your hunger. Does the quotient rule work? Yes. Now, if you want to see a proof, there's so many proofs on YouTube. If you want to, maybe during lunch, like proof of quotient rule, and you can see the proof. It's usually 10 to 15 minutes long, the video. So yeah, if you want to see the proof, go for it. Cool or not cool?
When we did it in blue, we were just using the product, right?
Quotient rule.
I mean, when we did it in blue.
Yes, the blue is just the power rule.
Oh, sorry.
Okay. All right, it works. So let's come over here, and this says differentiate. So that just means I'm going to take a derivative. Now, check it out. Ready? Who did ask when do I use the product rule? Look at this one. I have no choice. I must use the what? Quotient. There is no way around it. The top is the difference of squares, but nothing's going to cancel. You got it in the bottom. It's a sum of squares. Nothing cancels. Do you see that, guys? So there's no other choice but to do the quotient rule. Cool? So here we go. F prime. What do I do first? Yeah, go for it. Low, D high. So what do I write first? X squared plus 1 times the derivative of the top. What's the derivative of x squared minus 1? Plus or minus? Minus. The quotient rule is minus. Minus low D high minus x squared minus 1, high D low, x squared minus 1 times 2x again, all over perfect. If it were free response and they were to ask you what's the derivative, I guess you could stop there, but they're never going to ask. This is going to be like a multiple choice where they're going to have A, B, C, D, and you got to simplify. You're done with calculus. The rest is algebra. You're done with calculus. The rest is algebra, guys. If you wanted to, if you're super advanced, you can probably factor out a 2x. Yeah, I probably shouldn't do that. Okay. If you see it, go ahead and factor out the 2x and then cancel out the 1s. If you don't see it, if you have no idea what I'm talking about, just go ahead and do this. So if you do that, f prime of x is equal to 2x cubed plus 2x minus 2x cubed plus 2x. Does everyone know where the plus came from? What do you notice is going to cancel out? Perfect. 2x plus 2x is all over x squared plus 1, close it squared. What I was talking about earlier, guys, you see how this is a product in the top and this is a product? You could factor out the 2x, and then the x squares would have canceled out, and you would have 1 plus 1, which would have been 2. and 2x times 2, you get the 4x again anyways. But if you don't see that, it's okay. Look, we still got the right answer. More than likely, this would be a multiple choice question, and they would probably have that one in there, so they would force you to do quotient rule. Matter of fact, in a little bit, maybe we'll look at that packet that you guys still have. Do you guys still have it? Okay. Let's continue. Yeah, the practice test. No, let's not do it yet, but let's look at it. In a little bit, we'll look at it. Let's continue. Example 10, we never finished. No, because nothing's going to cancel out if I were to expand it. You know what I mean? On example 10, it says that I need a tangent line. For a tangent line, I need two things. What and what? Point and slope. They are nice. They don't have to give me that y value. They could have just given me the x value, and I could have figured out the y value by plugging in the x. Does it make sense? But they gave it to me. And then I already found the derivative. I found it. Look, there it is in blue, and there it is in red. So if I want the slope, I plug in what? Plug in 1 into whatever derivative you want. They're both the same. So y prime of 1 is equal to 1/2 minus 3/2, because 1 squared is 1. So I get, it looks like I get negative 1. 0.5 minus 1.5 looks like negative 1. Are we okay? All right, so what is my tangent line? I'm going to write it right here, guys. Tangent line, y minus 2 equals negative 1, parenthesis, x minus 1. Yeah, I could have distributed it, but I'm not going to. How do you feel? I'm going to go to Desmos because I want to see this graph. I thought I had it as a favorite. That's fine. Help me out with the equation, guys. What was my original equation? Y equals what? X squared plus 3 all over 2x. All right, so there it is. And what was my tangent line? Y minus equals negative 1, parenthesis, x minus. Yep, that's definitely a tangent. Look at that. Do you guys see it? Is this cool or what? Yeah. That's definitely. There is another tangent that's parallel to that, but they didn't ask me that. That would have been fun to do. Yeah, maybe it could be. I think it's pretty cool. I think you should embrace technology because we are in 2021, and you should be not only with your calculator but with all types of programs. All right, let's continue. We're done with that one. Are we ready for higher order derivatives? Yeah, I think we are. Relax, guys, relax. All right. You can take more than just one derivative. You can take a second derivative. You can take a third derivative. You can take. Remember what it means to take a derivative. It's just the rate of change, right? And instantaneous. So let's start at the very basic. If I give you a graph and the x-axis is in time, but the y-axis is in distance, feet or meters, it doesn't matter. So if I give you a position time graph, what is my slope? What does the slope mean from the position time graph? The instantaneous velocity. Do you guys see that? Change in y over change in x. Change in feet over second, feet per second. Now, if I give you a velocity time graph, so now my y-axis is feet per second and the x-axis is in seconds. And I find a slope. The instantaneous rate of change. What is that now? Acceleration. So the derivative of velocity is acceleration. If I give you an acceleration graph, feet per second or feet per second squared, and the x-axis is still in seconds, and you take a derivative of that, that's called a jerk. So the derivative of acceleration is a jerk. So if you want to offend your boy or your girl, you tell them you're the derivative of acceleration. So the derivative of acceleration is what? A jerk. There it is. Go be mean to someone. All right. Are we getting better? All right. Now, what is the notation? All right, guys. Focus. So It is understood, so let me give you the notation for any derivative. D to the power n, y, dx to the power n, where n is the derivative, is nth derivative. Let me explain the notation to you. N is the nth derivative. Nth. So if I tell you fifth derivative, you put a 5 in there. If I tell you seventh derivative, you put a 7 in there. If it's a polynomial function, all polynomial functions, if you keep taking derivatives, eventually you will reach 0. Because eventually you're not going to have a rate of change. Look what you're doing. You keep taking the instantaneous rate of change of the rate of change. The rate of change of the rate of change, and you do it again. The rate of change of the rate of change, and you do it again. The rate of change of the rate. Eventually you're going to zero out. Because there's not going to, like, you keep taking the derivative, you keep taking the rate of change of a rate of change, like eventually you're going to zero out. If it's a polynomial function. If it's a sinusoid, you're never going to zero out. Why would you zero out? So let's just, let's just do it with basic derivatives. Y equals, let's do x to the fourth. What's the first derivative of y equals x to the fourth? 4x cubed. Okay. What's the second derivative of 4x cubed? 12x squared. What's the third derivative? What's the fourth derivative? What's the, actually by this time, you either put parenthesis 5 or use Roman numerals. I've seen both of them. What's 5? 5, just the v. Fifth derivative, 0. If it's a polynomial function, it's going to zero out. Does that make sense, guys? All right, so there it is. This is how you say first derivative, y prime. You guys already knew that. How do you say second derivative? You can say y prime prime, or you can say d2y dx squared. And I know what you're saying, but Chavez, shouldn't that be the dx in parentheses? It's understood. It's not the x that's being squared. It's you're doing this. Look, dy dx means y prime, so d dx of that, there's two d's, d squared y over dx squared. Do you see the terminology, how we do it? So it makes sense, guys. It all makes perfectly sense. Y to the third power, usually you stop right here with primes. Any higher than third derivative, you start either probably doing it with these symbols. That makes sense, guys? Okay, so what does this mean right here? What does this d3y over dx cubed mean? What derivative? The third derivative. Write that down so you guys know. So if you see, what does this one mean up here? D squared y over dx squared. That means second derivative. Cool or not cool? Now don't tell me, guys. Please don't do this ever. Don't do that. That's nothing. Well, it's something, but it's not derivative. Cool? Well, it depends on how you look at it, but yeah, don't do that. The 2 has to be in the numerator. The nth derivative has to be immediately after the d, and then in the denominator, the n has to be immediately after the x. Cool? Okay, so I think now we're good. So look at example 11. What did it say? Find the what? So here we go. First 4 derivatives. I'm going to write y prime. Y prime equals 3x squared minus 10x. There we go. Y prime prime. Y prime prime prime. Y, and then after that, I just start writing Roman numerals. 0. Can you take more derivatives? Yeah, but they're all going to be 0. Like it doesn't, you know.
The derivative of 0 is 0.
The derivative of 0 is 0. Yes. I haven't seen one like that. All right, here we go. Let's see. All right, guys, focus. Let's see if we have conquered the product, quotient, and just little rules of derivatives here. So example 12, letter A. I have UV. I need the derivative of that. So first give me the derivative rules. Perfect. Yes. That's the product rule. Delta math is going to have this reversed. It's okay if you want to go that route. It's not a big deal. Are we okay right now, guys? All right, here we go.
Is it subtracted?
Yes. Yes. Here we go. I'm looking at it at 0. So good thing they didn't give me any other values in the terms that then at 0, at x equals 0, or whatever you want to call it. Yeah, it says x equals 0. So u of 0 is 5. V prime of 0 is 2. Plus v of 0 is -1. And then u prime of 0 is -3, right? All right. And then just 5 times 2 is 10. Negative times a negative is a positive, so 3. So I got 13. Are we okay? All right, letter B. What rule do I got to use? Quotient, u over v. So what's the rule? V, u prime minus u v prime over v squared. Let's plug in. What was v at 0? -1. Thank you, miss. What was u prime at 0? Was it 3? -3. Minus u of 0? 5. V prime of 0? 2. All over, what's v prime of 0? 2? No, wait. -1? -1 squared.
The bottom is just V, not V prime.
It's just v. Let's see what that number is, guys. 3 minus 10 over 1. So I see -7. Are we okay, guys? Okay. Let's look at letter C. Chavez, they mixed up the letters on me. It's okay. Go by low-D high, high-D low. What do I write first? U, V prime, minus V, U prime. Perfect. What was U? 5? What was V prime? What was V? Negative what? 1. What was U prime? And U again was 5, right? Okay, so let's see, what do we get here? We get 10 minus 3 over 25. So 7 over 25. Don't worry, Miss Parker. I'm going to upload the video. I'm recording. How do we feel? All right. Last one. If you just see a letter by itself, you just take the derivative, right? So 7v prime minus 2u prime. Uh-oh. You guys all right?
So whenever it's like that, you're touching
Yeah. All right. D dx of y is just y prime. Are we okay, guys? Okay. No? No, ask, please, because I can't read minds. Taylor, you okay or no? Oh, we're going to plug in, right? So here we go. I'm doing this. 7, what was v prime? 2 minus 2, what was u prime? So 14 plus 6, 20. Yeah, just boom, v prime. If it is, we're taking the derivative with respect to x. So, all right, guys.